Alright guys, so today we are looking at our 10.3 notes. This is our final section for Unit 10, which will go over triangle congruence proofs day 2. So we are starting to get a little bit more intense. Just as a reminder, you have already learned 5 methods for proving the triangles are congruent. Okay, here's number 1, 2, 3, 4, and 5. Remember, things that cannot be congruent are if you have all angles are the same, or if you have SSA or backwards ASS. All right, let's look at example 1, where it tells us to determine the relationship between the two triangles and whether or not they can be proven to be congruent. So I need to find the relationship here. First thing I notice is that they are right triangles. And if you write an arrow right across the 90, I know that this is my hypotenuse, so that means this is a leg that's congruent. Doesn't that look familiar? It looks like it's HO. So we're going to go ahead and write the two triangles are related by hypotenuse leg. So therefore, the triangles are congruent. They can be proven congruent because it's part of our triangle congruence theorems. Moving on to example 2. Let me move the mouse out of the way. Okay, determine the relationship between the two triangles and whether or not they can be proven congruent. This is the one I was talking about. I got an angle, and an angle. So they're related by angle, angle, angle. However, looking up here, that is not one of my triangle theorems. Therefore, the triangles are not congruent. Okay, and then the last one, example 3, determine the relationship again, and we're going to see if they are proven congruent. Okay, I'm going to start here. I know this is an angle, and this is a side. Same thing over here, angle, angle, side. This looks to be AAS or SAA, and that is option number 5. So they are congruent. All right, guys, let's move on to page 14. Okay. Example 4. Now we're looking at our flowchart proofs. These look really similar to your Delta Math practice, which you will be doing today. So they gave us that AC is perpendicular to BD. These are perpendicular, and they already drew out that they are right angles. We're going to fill in the reasons for these boxes. So statement number 1, it says, this was already provided for us, and they already said that angle ADB, talking about this angle, is congruent to this angle because they're right angles. Reason, perpendicular lines form right angles. Sorry, I was trying to jump ahead, but sorry guys, it is a long day. We had to go through these 2 boxes first. Okay, let's look at this angle right here. Angle ADB. ADB, now I'm talking about the right angle individually, is congruent to CDB. Well, I know that they're right angles because of the perpendicular lines. And if you remember from 10.2, we know that all right angles are congruent. All right angles are congruent. Next one, it says AD is congruent to CD. Did they mark that up? Yes, they did. This is congruent to that. How do I know they are congruent? Because it was given to me. I see the tick mark. It's there. It was provided. And then last one, angle A is congruent to angle C. Hey, I see it. It's there. It was given to me. All right, let's move on to example 5. I think we were just filling in the flowchart here. Example 5 looks like this is the full proof. Given all of this information, which was already put into our first box, I know that this was given, but I have to go back and mark it up. Did they mark up this? DE is congruent to DF? Yes, they did. AE is perpendicular to ED. It's that word perpendicular. I know that that means I'm going to have some form of right angle. So let's look where AE is. Here's AE. Here's ED. Therefore, this is a right angle. Same thing over here. CF is perpendicular to DF. This is also a right angle. I just wanted to mark those things up before I move on. Okay, there's no word bank here. That's why it's a little tougher. But we do need to know what about perpendicular lines. They create right angles. And we have to be very specific here. We got to look at each individual one. So we're going to start with angle E. And our first statement is going to be angle E is a right angle. Why is it a right angle? Because of the perpendicular lines. So we're going to write perpendicular lines form right angles. All right, I looked at angle E. Now I got to go and look at angle F individually. Angle F is a right angle. Why? Same thing. Perpendicular lines form right angles. A lot of writing. Okay, now that we've stated that they are both right angles and we've given our reasons why, now you can say angle E is congruent to angle F. And we know this because all right angles are congruent. And this was something we saw in 10.2. Okay, let's mark up what we know. We know this is an angle, this is a side. I like to mark up just one triangle. Okay, and knowing, hey, I know that these look like they could be vertical angles, right? Because they're right across from each other. Could I possibly put that down as a statement? Sure, right? I could say angle EDA is congruent to FDC. I just noticed that they look like vertical angles, right? And so we can say, hey, this is because of vertical angles. That means we got an angle that's also congruent with the other triangle. We got our three parts, a side, which is, or an angle, a side, and an angle, which is our ASA congruence. Remember, your proof always goes in that statement, which is, in this case, box number 6. I'm going to rewrite it here. Now we can say triangle ADE is congruent to triangle CDF. Okay. Biggest thing here is you have to look for what else could be congruent with the triangles. And in this case, it was obvious. I see vertical angles. Let's move on to example 6. All right. Ooh, just by looking at this, you should know, hey, I see vertical angles. Eventually, we'll get to that part. But for now, it looks like they already filled in our first statement, which is what was given to me. I'm going to go ahead and write down my reason. This is given. And I'm going to go and mark up what they did not mark up. AC and DB bisect each other. Okay. This is acting as a bisector, and so is this. That means this side is congruent to this side because AC was a bisector, but BD is also a bisector of AC, so this side is congruent to this side. All right. Now, let's fill out our statements. We need to say that these sides are congruent to each other. So let's start with DE. DE is congruent to EB. Okay, and AE is congruent to EC. And how do I know they're congruent? Because of a segment bisector, definition of a bisect. Let's write that down. Okay, and it's for both of them. Again, a lot of writing here. What else do we see? Well, remember, I noticed immediately that I saw vertical angles. Now, when we're in step 4, I can go ahead and say, hey, I got vertical angles. Let's be very specific. Don't just call this angle E. Call it by its 3 letters. Angle A to E to B is congruent to CED. Because of vertical angles. And now I'm going to go back, and if you're on Delta, I highly recommend you have an expo marker and you can mark up your Chromebooks as long as you make sure to wipe it off. Mark up what you have. Hey, this is a side, this is an angle, and this is a side. What does that spell? SAS. I know that's part of my congruence theorem, so SAS. And in the last box, we just write out what we were trying to prove and make sure that it is exactly in the correct order that they put it. Because if you are on Delta Math and you write it differently, it will count it wrong. Do we have, oh, one more proof, guys. Example 7. All right, in example 7, it looks like they've already written down given for us. First statement. This is going to be given. Okay. Sorry, I'm making a video right now. Sorry, guys. All right. Option number 2, or step number 2. Oh, I forgot. Let's mark up what we don't see. BC is congruent to AD. Oh, it looks like they already marked it up, which is good. And then BC is parallel to AD. Looks like they already marked that up as well. I noticed that in 10.2, a lot of you guys did not know what this means. I'm going to go ahead and write it. That means that these are parallel lines. Sorry, guys, the janitor walked in. I'm in here kind of late. And I got a little sidetracked. All right, let's move on. What else can I say about these? Oh, this problem is very difficult. Not super difficult, it's just, notice there are 4 triangles here. What are we even trying to prove? We're trying to prove that triangle BEC, I'm going to take a highlighter and I'm going to highlight BEC. B to E to C. I'm talking about this triangle is congruent to DEA. Alright, I don't really care about these triangles, but I'm going to use them because they're important. So far we have a side. What else do you guys see here? Notice these are what to each other? They are vertical. So let's go ahead and write that one next. BEC, so angle BEC is congruent to angle DEA. Therefore, we can write the reason, vertical angles. I need one more thing before I can prove that these triangles are congruent. So I got a side, I got an angle. It looks like I'm gonna need, not a side, because remember, ASS is not a thing. I'm gonna need some type of angle here. Going back to 10.2, we did talk about, hey, if we have parallel lines, where's my other pen here? I'm gonna use a blue pen. If I got parallel lines, I'm gonna extend these out. That means I have a transversal, right, that's being cut through. In this case, this could be my transversal. This is the inside, my interior, and I know that alternate interior angles are congruent to each other. Okay, so I can now state that BCE, let me use my black pen, angle BCE is congruent to DAE. And this is because of alternate interior angles. Okay. this was an angle, this was a side, and this is an angle. I got my 3 things, which is angle, angle, side, which is a congruence. Now I can write my proof here. Angle BEC is congruent to DEA because of angle, angle, side. Alright, that is all for today, guys. For this day, there's going to be a practice on Delta Math, so make sure you go and check that out. And good luck, guys. I will see you next time. Bye.